Practice question of the adjoint. This one two question is complete. The next one question is the verify the property of this one. Now solve the word file and verify. The first question is verify the property A adjoint A is equal to adjoint A multiplied by A equal to determinant of A into identity matrix. First we find the value of adjoint A. Then we find the cofactor of cofactor matrix and first we find the cofactor of the given matrix. Now we find the cofactor of the given matrix. First we find the cofactor of given matrix. First we find the cofactor of the given matrix. There are how many elements? 4 elements. Then there are 4 cofactors. First cofactor is C11. The value of the cofactor C11 is first row, first column cancel out, the remaining element is 4. The 4 is the cofactor of the C11. Then now we find the next cofactor C12. C12 equal to C12 is equal to the sum of the order of the element is 1 plus 2 is equal to 3. This is the odd number. Then we take the negative sign. Then the value of C12 is the first row, second column element cancel out, the remaining element is 3. Note down here the cofactor of C12 is minus 3. Now the next element is C21. C21 is equal to this is also the sum of the order element is 2 plus 1 is the odd number. Then we take the value is minus 21. Then cancel out second row, first column, then the value is minus 2. The cofactor is minus 2. Now the last C22 is equal to second row, second column cancel out, the value of cofactor is 1. C11 is equal to 4, first row, first column element cancel out, C12 is the odd number, then we'll take the value negative and the cofactor value is minus value is C12, first row, second column cancel out, the value is minus 3. Then the second row, first column value is 2 and the sum of the order is my odd number. Then take the value negative value minus 2. C22 second row, second column cancel out and the value is 1. The cofactor matrix is C is equal to cofactor matrix is equal to C is equal to, note down the value of the cofactor matrix, first element is 4, second element is minus 3, second row, first column element is minus 2, the last element is 1. This is the cofactor value of C, cofactor matrix. Now we find the adjoint A. Adjoint A is equal to transpose of the cofactor matrix. Transpose of the cofactor matrix. It means transpose of cofactor matrix. Transpose of the cofactor matrix. Then adjoint A is equal to transpose first row first column is -2 -3 1. First column interchange into the first row, second column interchange into the second row. This is the adjoint A, transpose of the matrix C. It is clear, everyone? Now LHS, take the left hand side. LHS is equal to A LHS is equal to, put the value of A and adjoint A in the next step. A, the matrix is given and the adjoint A is also find out in this step, multiply by the A. Now the multiplication apply both the matrix in the next step. First row first column element multiply, 1 multiply by 4, 1 multiply by 4 plus 2 multiply by -3. First row first column multiplication is complete. Now the first row multiply the second column, then we get the first row second column element. 1 multiply by 2 -2, 2 multiply by 1, and the first row second column multiplication is complete. Now no more column in this the second matrix. Now we come to the first row in first matrix. Then we multiply 1 by 1 each two column in the second matrix. If we multiply second row first column, then we will get the first element of second row. Then we multiply 3 multiply the corresponding element, multiply the 3 multiply by the 4, 3 multiply by the 4 plus 3 multiplied by 4 plus the second element of the second row is 4 and the corresponding element is 3. 4 multiplied by 3, 4 multiplied by -3. Now second row first column multiplication is complete. Now comes the last element multiplication, second row second column. 3 multiplied by 2, 3 multiplied by minus 2 plus 4 multiplied by 1, 4 multiplied by 1. These are the multiplication of two matrices. Now simplify in next step. 1 plus 4, here is 4, note down 4. 2 plus 3 minus 6, note down minus 6. The sign is plus. 1 minus 2, note down minus 2. 2 plus 1, 2. Now 3 4 is 12, note down 12. 4 3 is 12, note down minus 12. 3 2 is 6, note down minus 6. 4 1 is 4, note down plus 4. Now the simplify next step. 4 minus 6 minus 2 minus 2 plus 2 0. 12 minus 12 0. Minus 2 plus 4 minus 2. This is the left hand side. Now we take minus 2 is common in the matrix. The next step. Minus 2. Then the 1. This is the LHS side. This is the LHS side. Now we take the middle side. Middle part is the adjoint A multiplied by A. Middle part is equal to, the middle part is adjoint A multiply by A. Now the adjoint is find out in the last step. Here adjoint A is equal to now the middle part, put the value of adjoint A. Now the middle part, adjoint A multiply by A, the value of A middle part. Now we multiply both of the matrices in the next step. Multiplication is start by the first row and first column, then we get the first row first column element 4 multiplied by 1, 4 multiplied by 1 plus minus 2 multiply by 3, then the first row multiply to the second column. The first row first element is 4 multiplied by 2, then 4 multiplied by 2 plus minus 2 multiply by 4, and the first row second column multiplication is complete. Now we come in the second row. Second row first row multiply, second row first element is minus 3 and the first column first element is 1, then multiply minus 3 by 1, minus 3 by minus 3 by 1 plus second element is 1 and the corresponding element 3, then 1 multiplied by 3. Second row first column multiplication is complete. Now we come in the second row to multiply second column, minus 3 multiply by 2 plus 1 multiply by 4 . Now start the multiplication, simplify in the next step. 4 1 ja 4, write down 4 in the same place, 2 3 ja 6, write down minus 6 in the same place, 4 2 ja 8, note down 8 in the same place, 4 2 ja 8, note down minus 8 in the same place, 3 1 ja 3, minus 3, note down the same place, 3 1 ja 3, note down plus 3 in the same place, 3 2 ja 6, note down minus 6 in the same place, 4 1 ja 4, note down 4 in the same place. Now we simplify in the next step. 4 minus 6, result is minus 2, note down in the same place. 8 minus 8, 0, note down 0 in the same place. 3 minus 3, result is 0, note down the same place. Minus 2, minus 6 plus 4, minus 2, note down the same place. The value determinant is this. Now we take the common value minus 2 from the matrix. The next step, take minus 2 common from the matrix, then minus 2 is then common, then the value remaining is 1, 0 common minus 2, then the value is 0, and the minus 2 is common here, then the remaining value is 1. Note down 1 in here. This is the value of the middle value. Middle value and the left hand side value both are equal. Now we calculate the right hand side value. Right hand side value. Third part. RHS equal to first we find the value of determinant of A. Right hand side. Now we first to solve the value of determinant A. Determinant A is the value is 1, 2, 3, 4. Note down 1, 2, 3, 4. The value of the matrix I. I2 is equal to second order unit matrix. Is equal to where I2 is the second order unit matrix. Now simplify, multiply both the matrix. Then we find the RHS side. The first row multiplied by the first column, then we get first multiplied by first plus 2 multiplied by 0, 2 multiplied by 0. First row, first column multiplication is complete. Now we come to the second row. Now we come to the first row, second column multiplication. The corresponding element 1 multiplied by 0, 1 multiplied by 0 plus 2 multiplied by 1. Now the first row, second column multiplication is complete. Now we come to the second row. Second row first element is 3, 3 multiplied by 1, 3 multiplied by 1 plus 4 multiplied by 0, 4 multiplied by 0. The second row first column multiplication is complete. Now we come to the second column. Second column we get the multiplication of the second row, second column we get the last element of this matrix, 3 multiplied by 0, 3 multiplied by 0 plus 4 multiplied by 1. It is clear the multiplication of the both the matrix is complete. Now simplify. This is the determinant of the matrix. Now we solve by the determinant method. RHS is equal to, determinant is the solution of the difference of the multiplication of the diagonal element. This is the second order determinant. In the second order determinant is the value is the difference of the multiplication of the diagonal element. That is 4 multiplied by 1, 1 multiplied by 4 minus 3 multiplied by 2, 3 multiplied by 2. And identity matrix, note down the identity matrix. Simplify the next step. 4 minus 3 2 is 6. Identity matrix of order second is noted down here. In the right hand side, minus 2 in the identity matrix. Now LHS equal to middle value equal to right hand side. LHS, the value of the LHS is minus 2 multiply the unit matrix. Middle part is also minus 2 multiplied by the identity matrix. And the RHS value is also minus 2 multiplied by the identity matrix. Both are the all are the equal. Then the property of the A adjoint A equal to adjoint A into multiplied by the A is equal to determinant of matrix A multiplied by the identity matrix is verified. It is clear, everyone? The property is verified in here. Now second one, question of 3 by 3 order. First we find the cofactor of this. First we find the cofactor. How many elements in there? There are 9 elements. Then the 9 cofactor of this matrix. The cofactor is C11. In the first row, cofactor is C11, C12, C13. Second row, cofactor is C21, C22, C23. And third row, cofactor is C31, C32, C33. The order of the element is known as the cofactor of the row. It is clear, element. Now we find the one by one each cofactor. Find the cofactor. Find the all cofactor and all the cofactors. C11. C11, C12, first is C11, C12, C13, C21, C22, C23, C22, C23, C31, C32, C33. C11. Now find the value of the C11. First row, first column element is cancelled out. Then the remaining element in the form of the determinant. Now we find the one by one each cofactor of the given matrix. C11, C12, C13. The first row cofactor C21, C22 is second row cofactor. C31, C32, C33 is the third row cofactor. C22, C23 is the third row cofactor. And C31, C32, C33 is the third row cofactor. Now C11. First row, first column element is cancelled out. Then 1, 2, 2, 3. C12. The sign is taken minus because the sum of the order is odd number, then taking the sign is minus. C13, the sign sum of the order of the element is 4, then even number no sign change, and also the sum of the order is odd number, then take the minus sign. And C22 is the sum of the order is positive number, then the sign is no change. C23 is the order is sum of the order is the odd number, then taking the minus sign before the determinant. C31 is the even number, C32 is the odd number, then taking the minus sign before the, and the C33 is the even number, then no sign change. C12, it means first row second column element cancel out. 3, 2, 1, 3. 3, 2, 1, 3. Three, two, 1, 3 is the C12 first row second column cofactor. C13 first row third column element cancel out, and the remaining element 3, 1, 1, 2 note down here in the form of determinant. 3, 1, 1, 2. the form of determinant. It is clear everyone? C13. Now C21. C21 it means second row first column element cancel out 1 3 2 3 1 3 2 3 now C22 second row second column element is cancel out, then 2 3 1 3 2 3 1 3 2 3 1 3. It is clear? Now C23 is C23 second row third column element cancel out, then 2 1 1 2 2 1 2 1 1 2 1. Is clear everyone? Now C31 third row first column element cancel out, and 1 3 1 2 1 3 1 3 1 2. Is clear? C32 third row second column element cancel out, 2 3 3 2 2 3 3 2 2 3 3 2. C33 third row third column element cancel out, 2 1 3 1 2 1 3 1 2 1 3 1. These are the cofactors of the matrix A. Now we simplify of C1 first cofactor in the form of the determinant, and the determinant value is solved by the difference of the multiplication of the diagonal element. It is clear? First we multiply the diagonal element, after that the subtract, then we find the determinant of second order, which is the C11 cofactor. 1 multiplied by 3 minus 2 multiplied by 2 equal to 3 minus 4 is equal to minus 1. It is clear everyone? Now the come to the second cofactor C12. C12 means the difference of the multiplication of the diagonal element. Determinant value of second order 3 multiplied by 3 minus 1 multiplied by 2, that is equal to minus 3 3 is 9 minus 2 equal to minus 7. Now the first row last element determinant equal to the difference of the cross multiplication of the element 3 2 is 6 minus 1 1 is 1 equal to 5. Equal to minus the difference of the cross multiplication element 3 1 is 3 minus 3 2 is 6 is equal to minus 3. Now C2 2 2 3 is 6 minus 3 1 is 3 equal to 3. Now minus equal to minus 2 to the 4 minus 1 simplify equal to minus 3. Now the last row C31 element 2 1 ja 2 minus equal to 2 1 ja 2 minus 3 1 ja 3. Result is equal to minus 1. Now C32 minus 2 2 ja 4 minus 3 3 ja 9 is equal to minus plus 5. Now we come in the last cofactor is equal to 2 1 ja 2 minus 3 1 ja 3 is equal to minus 1. So these are the cofactor of the given matter. Now we find the cofactor matrix. Cofactor matrix of A equal to C. Symmetry order cofactor matrix C. The first element C11 is minus 1. C12 is minus 7. C13 is 5. After that, second row, first column C21 is 3. 3 3 minus 3. 3 3 minus 3. Now we come in the last row, cofactor C31 minus 1 5 minus 1 minus 1 5 minus 1. These are the cofactor matrices. Now we find the adjoint A. Adjoint A is equal to Transpose of the perfector matrix. Of perfector matrix is equal to adjoint A is equal to transpose of the cofactor matrix C. That is transpose of the cofactor matrix C. That is this adjoint is equal to transpose of the cofactor matrix A, that is the transpose of the cofactor matrix C. C is transpose. Now the calculating the transpose of the next step of cofactor matrix. Transpose first row, first column element -1, 3, -1, then -1, 3, -1, interchange. Second row element -7, 3, 5, -7, -7, 3, 5. And the last element 5, -3, -1, 5, -3, 5, -3, 5, -3, -1. This is the adjoint of A. This is the adjoint A. Now we take proof the verify the property. What is the property? Property is verify the property verify the property now we first LHS take LHS the first part is equal to A multiplied by adjoint A. A multiplied by the adjoint A. Now note down the value of A and adjoint A after then the multiply. A is equal to adjoint A Now, how many column in the matrix 3, how many row in the matrix 3, the row and column element are equal, then the multiplication is possible. Multiply, first we take the first row and multiply one by one each column of the second matrix, then we get the first row element. After then we take the second row and multiply one by one each column of the second matrix, then we get the second row element of the new matrix. And finally we take the third row and multiply one by one each column of the second matrix, then we get the last row element of the new matrix. Now start the first row. Delete. First row element is 2, 2 multiplied by 1, 2 multiplied by minus 1, plus 1 multiplied by 7, minus 7, plus 3 multiplied by 5, 3 multiplied by 5. Now we take the first row multiply to the second column, 2 multiplied by 3 plus 1 multiplied by 3 plus 3 multiplied by minus 3, 3 multiplied by minus 3. Now the first row multiply the last column, 2 multiplied by minus 1 plus 1 multiplied by 5, 1 multiplied by 5 plus 3 multiplied by minus 1, 3 multiplied by minus 1. The first row last column multiplication, 2 multiplied by minus 1, 1 multiplied by 5 and 3 multiplied by minus 1. The first row multiplication is complete. Now we come into the second row element. Now the second row multiplied by the first column, 3 minus 1 to minus 3, 1 multiplied by 7, minus 7, then minus 7, 2 multiplied by 5 plus 10. Second row multiplied by the second column, then 3 multiplied by 3, 9, 1 multiplied by 3, then plus 3, 2 multiplied by 3 minus 6. Now the second row multiplied by the last column, 3 multiplied by 1 minus 3, 1 multiplied by 5, then plus 5, 2 multiplied by 1 minus 2. Now we come in the last row element 1, 2, 3 multiplied by first column, Then 1 multiply minus 1, answer is minus 1. 2 multiply by minus 7, minus 14, note down minus 14. 3 multiply by 55, then answer is 15 plus 15. Now third row, multiply the second column. 3 1 is 3 plus 2 3 is 6, and 3 multiply by 3 minus 9. Now last row, multiply last column. 1 multiply by minus 1, minus 1. 2 multiply by 5, then the result is 10. And 3 multiply by minus 1, the result is minus 3. Now simplify in the next step. Two multiply by 1 minus 1. 2 multiply by 1 minus 2 minus 7. 1 multiply by minus 7, write down in the minus 7. 3 multiply 50, 3 multiply 5, 15, note down 50. 2 multiply by 3, 6, note down 6. 1 multiply by 3, note down 3. 3 3 is 9, minus 9, note down minus 9. 2 multiply by minus 1, minus 2. 1 multiply by 5, result is 5. 3 multiply by minus 1, result is minus 3. Now simplify. Simplify this matrix. simplify of this matrix. Now simplify in the next step. -2, -7, -9, -9 plus 15. The result is 6. -9 plus 15. 9 minus 9, 0. 9 minus 9. -5 plus 5. -10 plus 10. -12 minus 6 -5 plus 5 -15 plus 15 plus 15. 9 minus 9 10 minus 4. Now simplify in the next step. The value of -9 plus 15 is 6. Note down 6. 9 minus 9, 0. Note down 0. -5 plus 5, result is 0. -10 plus 10, result is 0. 12 minus 6, 6. -5 plus 5, 0. -15 plus 15, 0. -9 plus 9, 0. 10 minus 4, 6. Note down 6. Now the value of the first part is complete. First part. Now the value is 6 is common of each element of the matrix. Then we take outside of the matrix. Six is common to each part of the matrix. Then the remaining element in the matrix is 1, 0 0 1 and 1. This is the identity matrix of third order. Then first part, equal to I 3. Where I3 is equal to where I3 is equal to identity matrix of 3 by 3 order. That is part first. Is complete. Now we come in the second part. Second part. Is equal to, what is the second part? Adjoint A into A second part is adjoint A into A. Now the adjoint A value is also find out. What is the adjoint A value? This is the adjoint A value, not down here, and value is also given in the question. Both the value put in the second part. Is clear everyone? Adjoint A value is calculated in here. This is the adjoint A value. Into A is given, A is given here. The question wrote down here. Now the multiply both the matrix adjoint A and the matrix A one by one. First row element is -1. -1 multiply the first column, -1 multiplied by 2, then the value is -2. Note down -2. Second element is 3 and the corresponding element is 3. The 3 multiplied by 3, the value is 9 plus 9. And the last value of the first row is -1. Corresponding value is 1. -1 multiplied by 1, then the value is 1. Note down -1. The first row, first column multiplication is complete. Now we come to the second column multiplied by the first row. -1 is multiplied, the corresponding element of the second column is 1. Then -1 multiplied by 1, value is get -1. Note down -1. The first row second element is 3 and the corresponding element in the second row is 1. 3 multiplied by 1, then the result is +3. Note down +3. -1 is multiplied by the corresponding value in the second column is 2. -1 multiplied by 2, the result is -2. Note down -2. The first row second column multiplication is complete. Now we come in the last column multiplied by the first row. -1 is multiplied by 3, the result is -3. 3 is multiplied by 2, the result is +6. -1 is multiplied by 3, the result is -3. Now the first row multiply of each column, all of the column of the second matrix. Now we come to the second row. Second row multiply the first column by the corresponding element. -7 multiplied by 2, the result is -14. Note down -14. -14. After then -7, 3 is multiplied by 3, then the result is 9 plus 9. And 5 is multiplied by 1, the result is +5. -7 is multiplied by 1, the result is -7. The second row multiply second column. 3 multiplied by 1, the result is +3. The 5 is multiplied by 2, the result is +10. It is clear. First element is second row is -7 multiplied by 1, result is -7. 3 is multiplied by 1, the result is 3 multiplied, note down 3. And 5 is multiplied 2, the result is +10, note down +10. Now the second row multiply the last column. -7 multiplied by 3, -21. 3 multiplied by 2, +6. 5 multiplied by 3, +15. Now the second row multiply all the column of second matrix. Now we come to the last row of the given matrix and multiply one by one each column. First we start third row multiply by the first column, then we get the third row first element. 5 multiplied by 2, then 5 to the 10, note down here 10. -3 multiplied by 3, then -9, note down -9. -1 is multiplied in the corresponding element in the first column, 1, then the -1, note down -1. Third row first column multiplication is complete. Now we come to the second column. 5 is multiplied by 1, the result is 5. -3 multiplied by 1, the result is -3. -1 is multiplied by 2, the result is -2. 5 is multiplied by 3, result is 50. -3 multiplied by 2, -6. -1 is multiplied by 3, -3. Now each row, each column multiplication is complete. Simplify the next step. -2, -1, -3 plus 9, result is 6, note down 6. -3 plus 3, result is 0, note down 0. -3, -6 plus 6, result is 0. 14 minus 14 plus 14, here is 0, note down 0. Minus 7 plus 13, the result is 6, note down 6 in here. Minus 21 plus 21 is 0, note down 0. 10 minus 10, 0, note down 0. 5 minus 5, note down 0. 15 minus 9, result is 6, note down 6. This is the two by two. This is the 3 by 3 matrix, and the common value in this matrix is 6. Now we take the common value 6 outside from the matrix. In the next step, take 6 is common from the matrix, then the remaining value in the matrix is 1, 0, 6 is outside from the matrix, then the remaining value is 1. If 6 is taken outside from the matrix, then the remaining value is 1. This is the third order identity matrix. Now this is the I3. Second part, the second part is also equal to the first part. Now take the last part. Last part is equal to third part. Third part equal to the last part. the last part, equal to determinant of A, the value of A is given, the determinant of A, the value of A is given in the question, note down here. Into I3. Now simplify the third order determinant value, expand according to the first row. The value of determinant is equal to A11 A11 multiply C11 plus A12 multiply C12 plus A13 multiply by C13. This is the value determinant according to the first row. Into I3. Into I3. Now A11 is 2. C11, the C11 also calculate in the cofactor matrix. C11 value is -1. Put -1 into -1 plus A12 is equal to 1 and the corresponding value is C12 is the cofactor of C12 is calculated in earlier. C12 is -7. Note down -7 -7 plus A13 is 3 and the cofactor is C13 is 5 note down 5 but close the bracket and multiply by the I3. The next step, 2 multiplied by 1 -2 + 2 + 1 + 2 + 1 + 2 + 1 + 2 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 1 multiplied by 7 minus 7, 3 multiplied by 15 plus 15, bracket close. Then next step, minus 9 plus 15 is equal to 6 by I3. This is the third part. Now the first part, second part and third part, all of them are equal. Hence first part equal to second part equal to third part equal to 6i 6i3. Then verify the property. Clear everyone? This is the long question. So first we calculate the cofactor of the each element of the matrix. After then the cofactor matrix, then the transpose of the matrix equal to adjoint of A. Then we take the first part A multiplied by the adjoint A. Then the value of the first part is 6i3. I3 is the identity matrix of third order, and the second part adjoint A multiplied by the A is also equal to 6i3, and the third part is also equal to 6i3. All of the value are equal. Then verify the property. It is clear everyone?